Hi, welcome to Processing Motion Part 7. Last time we talked about wave motion, and today we're going to talk about what happens when waves interact with each other. And specifically, we're going to focus on wave interference patterns. So basically, what happens when a wave hits a wave. And the short answer is if the peak of a wave or the crest, the part of a water wave that you see the surfers riding on top of, when a crest hits a crest, you get constructive interference. You get a taller wave, basically. When a trough hits a trough, meaning the part of the wave that sort of goes down, you also get constructive. So you get a deeper trough when two troughs meet. And if a crest meets a trough, you get destructive interference. They can cancel each other out to some extent. If they're equal in magnitude, they can actually completely cancel each other out, making the wave disappear, which is an interesting effect. So we'll start by looking at some static representations of an interference pattern, and then we'll use a processing sketch to draw an interference pattern that's sort of dynamic. So let's switch over here. Here's a static interference pattern that I've drawn. The pink and the green represent two different sources, so this is a two-source interference pattern. The solid lines represent a crest. The dashed lines represent a trough. So anywhere you see a solid meeting a solid or a dashed meeting a dashed, you're going to get constructive interference because there's a match there. Anytime you see a dashed meeting a solid line, you're going to get destructive interference. And so you can see patterns kind of emerge. A couple of my students tweaked this image, and here's an example where they've used dots to represent constructive and destructive interference, so you can kind of see that pattern. In the next example, we've used lines to represent those. So green represents destructive and purple represents constructive, and you can kind of see these patterns sort of emerge. So to draw one of these dynamically, we would want these dashed and solid circles to be emanating from their central position and moving outward, which is actually pretty tricky. There's a couple different ways to draw these dashed circles in processing, but it's a little bit tricky to get a handle on, and it took me a while to figure out this method, but I'll share it with you. And before we switch over to the processing window, I want to sketch out a couple concepts that we're going to use. So let me get set up here for a second. Okay. If these are our two sources and we've got solid circles and dashed circles going out from each other, and we're going to imagine this being inside a processing window. So processing windows are rectangular, and they have a certain width. Not a very straight line, but we can survive that. And what we want to be able to do is control the spacing between these two sources, because the pattern that we get is going to result from the spacing of the sources, their wavelength, their frequency, which depends on the wave speed, and the phase of the waves. So our sources will be in phase for this project, but you could make one where they're out of phase. You'd get a different pattern, right? So we want a simple mathematical way of controlling this spacing, and we're going to do that by introducing a spacing parameter. So let's imagine that this point is, say, 0.25 times the width of the window, and say this location is 0.75 times the width. So they're sort of evenly spaced, right? We have one at 1/4 and one at 3/4. Well, we could introduce a spacing parameter that can control this. And I'm going to call it S. So in this case, if S is 0.25, 1 minus S would be 0.75, which defines that position over there. And the X position for a given source would be S times W, or times the width. So anytime you want the X position here, you would do S times the width, and if you wanted the X position here, you would do 1 minus S times the width. And that's how the spacing parameter controls it. So let's do some hypothetical examples, or some extreme examples. If you did S equals 0, it would place this circle at that position, meaning the far left side of the window, and then 1 minus S just gives you 1. 1 times the width would put the other one all the way at this end. So you'd have one circle at the far left and one circle at the far right. If you set this parameter equal to 0.5, that places it right in the middle, and 1 minus 0.5 is also 0.5, so they would be overlapping with each other, right in the center of the screen. So by using a parameter of 0, you've got them all the way at the edge of the window. By using the parameter 0.5, you've put both of them right in the middle. So every value between 0 and 0.5 increments that spacing kind of in between. And we're going to use that mathematical relationship to control our processing window and where things appear on the screen. All right, so one more thing. We're going to use arcs to draw, not that random line. We're going to use arcs to draw our dashed circle. So we need to understand what an arc is in processing. So in processing, an arc is an ellipse segment. And we're going to be using circles, so arc is really a segment of a circle, but in processing you can do an arc as any ellipse if you would like. And the variables that are involved are the XY position of the circle or ellipse, the height of the ellipse, the width of the ellipse, and then to designate your arc, you give it two angles. So suppose we wanted this arc here. We wanted to draw that piece of this ellipse. We would designate that first angle and the second angle so that we're taking up that sort of piece of the pie, that slice of pizza there, so that this is designated by angle 1 and this is angle 2. So by defining your position of your ellipse, your height and width of the ellipse, and the segment that you want to take out, you've defined the arc. So the input parameters are x, y, w, h, theta 1, theta 2. So these define the ellipse. And these right here define the segment of the ellipse. And as a brief reminder, this position right here is 0 radians. This position here is pi over 2. This is pi. And this is 3 pi over 2. And if you go back around to the beginning, this is also 2 pi at that first position. And proportionally, anything in between those gives you a fractional equivalent. So if you wanted to go exactly halfway between these 2 points, between 0 and pi over 2 gives you pi over 4, and so on throughout the diagram. Okay, so now that we have a little bit of background information about the math that we're going to use in the sketch, let's go over and switch to processing. And as a side note, this will be our first video that includes object-oriented programming. When we define we'll start by defining the classes so you sort of get a sense of it, but it can get a little bit tricky. So let's go ahead and switch over. Okay, so I normally like to type the code live as I'm explaining it, but for object-oriented code, the pieces are so interrelated to each other that as I started recording this, I kept referring to parts of code that I had not typed yet, which makes for sort of a confusing video. So I'm going to start with everything on the screen. I've created 2 tabs for drawing the solid circles and the dash circles so that those 2 classes are sort of separated out from the main code, and then we'll go look at the way the actual program works. So to draw solid circles, which is the easy part, I've defined a class called solid, and the only variable that it needs is the diameter of the circle. So we're just going to draw concentric circles. What's the diameter? So the display function will draw 2 ellipses. The first one is at that spacing parameter position, and then the second one is at 1 minus the spacing parameter, which gives you that even spacing. And remember, those can go between 0 and 0.5, and that's multiplied by the width of the screen. And then we draw it at 0 for our vertical position. There's a translate function which moves everything to the center of the screen, so that's why those will be 0. And then the height and width are diameter. So whatever we set the diameter of the circles to be. And this is what controls those diameters. We wanted the sketch to be dynamic, so we want these circles these wave fronts to emanate from the center and go outward. And so basically we'll take the diameter of the wave, or of the circle representing the wave fronts, and then add a speed value to it. So the higher the speed, the quicker those circles are going to grow and go outward. So that's the solid circle. Dashed is significantly more complicated. It still only requires 1 parameter, which is basically the diameter of the dashed circle. And the grow will work exactly the same way as before. But for drawing the dashed circles, we're going to use this for loop here. So what we're going to do is go in increments of pi over 16. So a 16th of the circle, and then go to the next increment, a 16th of the circle over, skip a space, a 16th circle over, all the way around a full circle, so that we're taking pieces of arcs all the way around. The first one is going to be centered at that spacing position. The second one is going to be at the 1 minus spacing position. And again, those can vary between 0 and 0.5. 0.5 putting it in the center, 0 putting it all the way on the edge. The code here is exactly the same. These are going to have the diameter. They're going to be located at the center of the screen, vertically oriented. And then this is what controls the start and finish angle of the arc. So as I said before, these increments are going to go up by pi over 16 each time. And so for half of that pi over 16, it's going to be a gap. And then for the other half of the pi over 16, we're going to draw an arc in that space. And once you see it on screen, you'll kind of, you'll get a visual sense of what I'm talking about there. But that's definitely the most complicated part of the code. And then these are going to be open arcs, which means we're not going to have a fill that fills in the arc shape. Okay, so that's how you draw dashed circles. I'm sorry, solid circles. This is how you draw dashed circles, and the functions controlling those are display and grow. Okay, so we're going to draw 4 dashed circles and 4 solid circles for each one. We could certainly set up a loop to draw these, and you would really want to do that if you wanted your animation to go forever, meaning you wanted to constantly be producing new solid and dashed circles. But I like for the animation to pause at some point so that you can see what it looks like when it's not moving. Then we have a few variables here. W is going to represent the wavelength divided by 2. So how far apart the waves will be spaced. The spacing variable is going to control how far apart the 2 sources are. And then the speed variable is going to control how fast the waves are traveling. Void setup is straightforward. We set the background to black. We set the size to be a rectangle that's a little bit wider than it is tall. The beginning of draw is pretty straightforward. So again, we don't need the background here, do we? I guess it doesn't matter. You want the background under draw as well, because otherwise it won't refresh every iteration through the code. We're going to no fill on our circles so that we just see the crest and trough edge. And then we're going to draw, this is going to draw a sort of a blue line down the center of the screen, and you'll see it's going to basically just indicate where some constructive interference is taking place. Okay, so we're going to use white lines for our circle, and we're going to translate to the vertical center of the screen so things are moved to the middle. Okay, so this is where it gets a little bit tedious, and again, you could set up a loop to do this, but for only this number of circles, it wasn't immediately obvious to me how to set up the loop, so, and it's not very difficult to just copy and paste this, 8 times, but I'm basing when it starts to draw a new circle on the frame count. So frame count counts how many iterations the code has been through. So, it goes through the code once, that's 1, it goes through the code a second time, that's 2, and so on. And I want that to be, my if statement is a function of W, which is the wavelength of the waves. So at whole number increments of the wavelength, or I should say half the wavelength, we want to draw the next circle. So notice here, this is DC, so we're drawing dash circle here initially. And then once we get to the next whole number multiple of the half wavelength, it draws a solid circle. And then we get to the next whole number multiple of half the wavelength, draws a dashed, and then we get a solid circle, and then a dash circle, and then a solid circle, then a dash circle, and then a solid circle again. And then this just some text that labels that line that we drew down the middle of the screen that you'll see. And then once we get past the 8th circle, I put no loop, so that just kind of pauses the program so you can see it stop there, right? And keep in mind that this dashed and solid class draws these concentric circles at two different positions, at the first spacing parameter times the width, and at this one minus this spacing parameter times the width. So for each time you draw this, you're actually going to see two circles being produced on the screen. So let's see what it looks like. So as you see, it starts with a dashed circle down the center, then we get a solid circle, then we get a dashed, and it keeps going like that. And you can see the blue line I drew down the middle of the screen, just to kind of show where it's symmetrical. And you can see at any given point, that's a line of constructive interference. I started to draw the other lines of interference, but it got a little cluttered. So there you go. There's an interference pattern. We saw like sort of where it comes from, and you can start to tweak this stuff around a little bit. Like you can make the wavelength smaller. And you can see the waves get closer together. We can kind of exaggerate a little bit. So make the wavelength significantly bigger, and you'll see the waves get a lot further away from each other. So we could put this back to 150. You can move these things closer and further apart. So let's look at those extreme examples. 0 should move them all the way to the edge. So you can see there's one at this edge, one at this edge. Let's not go quite 0.5, let's go 0.45 or something, to where they'll be really close to each other in the middle of the screen. At 0.5 they would be exactly overlapped. So you can see slightly different patterns based on the spacing. There's still some general things that stay the same, but it'll look quite a bit different. I kind of like the way that 0.333 looks. And then the wave speed, at 0.5 it was doing that. If we increase it significantly, you can see the waves moving out much faster rate, so they get kind of spaced out a lot faster. So that's another one that's kind of interesting to play with. Yeah, those are the main things to tweak. And then you could play around with the phase, and you could come up with a way to do this as a loop. But for 64-ish lines, 60 lines if you count the spaces here, it works pretty well. Okay, so one more thing I wanted to tell you about. Really cool educational website called Cadenza. So cadenza.com. Right now they have 38 courses posted. These are all about technology and art. A lot of really cool options. I'm currently looking at Dan Schiffman's Nature of Code on Cadenza. This is based on P5. And then I also looked at Introduction to Programming with P5. And this has Casey Reese, who helped make processing initially, Lauren McCarthy, who did P5, and then Chandler McWilliams worked with Casey Reese to make this Form and Code book, which the book is cool. I've looked at some excerpts and stuff online, but I haven't read the full thing yet, but I can tell it's going to be awesome. And you can look at the code examples here. Some of these are used in other places in the sort of processing ecosystem, but if you look at this Form and Code code examples, there's some really good stuff here. So, okay, so that's all I've got for this, for part 7, and thanks for listening. See you next time.